the warm-up. Number 2 is not difficult in the geometry sense. It's just difficult in the algebra sense. We know that it's a parallelogram. They give us the base. They give us the height. We just need to find the area. So we need to remind ourselves how to multiply radicals. One way that you can do this is multiply the integers first. 7 times 5, 35. And then multiply the radicals. Square root 2 times square root 2, oh, it's 2. Square root 2 times square root 2 is 2. Let's pretend you forgot that. That would be okay. You could say square root 2 times square root 2 is square root 4, but 4 is a perfect square, so the square root of 4 is 2. Either way, you get 2. 35 times 2, 70 feet squared. All right, 14, take a look at that one. We have, what kind of triangle? What's that triangle called? What's its classification? Yes, we have an obtuse triangle. The curious thing about an obtuse triangle is that it's the only type of triangle where the height falls outside the triangle. The altitude falls outside the triangle. Remember that from last semester? So we have our base and we have our height. This is the figure we're trying to find the area of, but to find the area of this, we need to use the altitude, and the altitude falls outside the triangle. So in number 14, the only thing that you needed to know is that I wasn't supposed to use that 9.2 at all. It was a distractor. You had to know not to use it. So base times height divided by 2 meters squared. I'll let you do the math. Number 16, we are in luck because that is a square, and the hypotenuse is 25 root 2. So this one follows the pattern beautifully, which we love. X root 2. 25, 25, 25 root 2. So we know that the area is side squared, or base times height, or length times width. You can do any of them, and so 25 squared. Okay. So now we know. All right. You are going to encounter problems like 19 a lot in this unit. Find the area of the shaded region. Every time you need to find the area of a shaded region, you need to begin by writing a strategy. To find the gray area, our strategy is going to be area of the large rectangle minus the area of the small rectangle. All right, we all know the area of the large rectangle. It is 25 times 17. 25 times 17, 425. Now we need to subtract the area of the small triangle. To find the area of a triangle, you need a base and height. So far we have a base, we don't have a height. But we do know in a rectangle that opposite sides are congruent. So we can do Pythagorean theorem unless you've already memorized this triple. We can do Pythagorean theorem to find the height of that one. So this is a good multi-step problem. So the height of that one is 15. Is that what y'all are getting? It is a Pythagorean triple. So the height, oh, I forgot to divide by 2. Whoa, that one you don't divide by 2. Never mind. Tanton's going crazy again. Here we go. Base times height divided by 2. So this should have said triangle. Nice. I called the triangle a rectangle. You'll forgive me, right? Questions about how I did that?